If f and g are both differentiable, then here is the product rule. The derivative of the product f times g is the derivative of f times g plus the derivative of g times f. And the quotient rule, the derivative of the ratio f of g is the derivative of f, the top function, times g minus the derivative of g times f, all of that divided by g to the power of 2, provided obviously that g of x is not 0. Let's start now to really understand the product rule. So first of all, this is about taking derivative of a product. In the product there are two functions, f and g. Because the way it is written that f is before g, I'm going to call f the first one. And here is the rule. Differentiate the first one times the second one, plus differentiate the second times the first. Let's take our first example using the rule. So we are going to follow. The first one is going to be e to the x and the second x to the 4. This is totally symmetric. You can switch them and then the first one will be x to the 4. But it really doesn't matter. So, in this order, we will differentiate the first one times the second, plus differentiate the second times the first. Now I'm going really to differentiate the two functions that still needed to be differentiated here. The derivative of e to the x is e to the x, and the derivative of x to the 4 is 4x cubed. So I'm going to use that to replace the two functions that have the little prime. So this is replaced by that. This is just copying. This should be replaced by 4x cubed, and this is just copying. In this specific case, I can distribute x cubed e to the x and get this as my answer. Let's go again over the product rule. Differentiate the first times the second, plus differentiate the second times the first. Example, the first function will be 5 times x to the power of 2 plus 3, and the second will be ln of x. I am including the 5 in the first function. I don't want to apply two rules at the same time, so I advise everybody to apply just the product rule instead of the constant rule with the product rule. So I will start by just joining the 5 as 5 times x to the power of 2 plus 3. All of that is going to be the first function. Differentiate the first times the second, plus differentiate the second times the first. Now when we will differentiate the first one, I will take into account the constant rule. So using the constant rule, I will get 10 times x as the derivative of the first function. And for the ln of x, we know that the derivative of ln of x is 1 over x. So we are going to replace this by 10x, copy, replacing this by the derivative, which is 1 over x, and copy. Now let's go over the quotient rule. The quotient rule, again, you have a function over a function. I will call the top function also the first function, and the gx, the bottom function, as the second function, because if you have two functions, the first one is always the one on the top. So I will start by making a long fraction line. On top, it's almost the product rule with only one difference. You will see. Differentiate the first times the second, differentiate the second times the first, but now you can see that we have minus instead of plus. Now, under the fraction line, I'm just going to copy the function gx and square it. So this is g to the power of 2 of x. So the reason for me to say differentiate the first times the second, then differentiate the second times the first, because if you keep of the order of the product rule that I gave you, then on the fraction line for the quotient rule, you have exactly the same with only one difference. Instead of a plus, you have a minus. And here's our first example. So the first function, the top function, is 5x minus 4. So we start by a long fraction line, differentiate the first times the second, minus, be careful, it's a minus, differentiate the second time the first, or well, just copy the function on the bottom and square that. So now we're going to replace the two differentiation as we need. So the derivative of 5x minus 4 is just 5. So I'm going to get here 5, and here I'm just copying minus, copy the minus, differentiate that, and you get 4x plus 1, and copy that. We are done. We don't want to simplify too much here. Let's again go over the quotient rule. We will start with the long fraction line. On the fraction line, here it is. Differentiate the first or the top one times the second one minus differentiate the second one times the first one or the top one. And under the fraction line, we're going just to square g of x. And another example. Let's differentiate e to the x over x to the 4. We start with a long fraction line. The first and the top function here is e to the x. So we need to differentiate e to the x times x to the 4 minus, now we need to differentiate x to the 4 times e to the x. And in the bottom here, we're just going to square x to the 4, which if you want you can write as x to the power of 8. So let's finish up the problem by differentiating e to the x, and we get e to the x. Copy, minus, the derivative of x to the 4 is 4x cubed. Copy, and we are simplifying this one. And you can see here that you can distribute, if you want, e to the x times x to the power of 3, and we can get that. Now you can see that we can cancel out some of the x's here, and we can end up with a simplified solution as being e to the x times x minus 4 over x to the power of 5. Here is a little challenge problem. We would like to differentiate the function f(x) equals 5x e to the x over ln of x. There are many ways actually to do this one, and I will start with this one. So the first thing that I will do is I will view this as a quotient in which the top function is a product. But if I would like to view this first of all as a quotient, I will apply first the quotient rule and the quotient rule only. We only apply one rule at a time. So let's apply the quotient rule. Differentiate the first, which is 5x e to the x times the second, minus differentiate the second times the first over just square the ln of x and put it under the fraction line. So now you can see that I'm just getting rid of the easy part. So what I did here, I just replaced the derivative of ln of x by 1 over x, because now I really need to be focused on the derivative of the product, which is 5x e to the x. It's not only a product, you can also use the constant rule if you want, but I will never use two rules. So what I'm going to do, I'm going to apply the product rule of 5x e to the x, and again, I will take the first function as being 5 times x. so I will not be confused with two rows at the same time. Here is a little step that, just help me to simplify even more. And now what you see, I'm just replacing the derivative of 5x e to the x by the derivative of that using the product rule. The derivative of the first one, which is 5x, is 5 times the second one, which is e to the x, plus the derivative of the second one is e to the x times the first one, which is 5 times x. I can simplify a little more because if you can see, I can distribute 5 times e to the x, and I can even more distribute here. Okay, and when I do that, I can find out actually that I get 5e to the x times ln of x plus x ln of x minus 1, all of that over ln of x to the power of 2. We are going now to redo this problem, but now in a different way. I'm going now to view this as a product in which the first one is a quotient. It means that first of all I'm going to use the product rule. We will differentiate the first times the second plus differentiate the second times the first. Now I need to be focused on the derivative of the first. For this I will need to use the quotient rule. So the first and the top function is 5x, and the second function or the bottom function is ln of x. Please be careful here. You want to have this as one unit because all of that is multiplied by e to the x. So here I am applying the quotient rule. The derivative of the top is 5 times the bottom ln of x minus the derivative of the bottom, which is 1 over x, times the top, 5x, all of this over ln of x to the power of 2. There's a little bit of cancellation here because I want to show you that I get exactly as before. So after the cancellation, I get that. Okay. Now I can distribute e to the x and 5. And as you can see, I get this. So I will simplify a little more because I would like really to get what we got before. So instead of writing x over ln of x, I'm writing x times ln of x over ln of x to the power of 2. So it's a common denominator. And I get this exactly as before. Differentiation of a function is unique, so obviously I should get exactly as before.